Yes,
Both,
sir.
both. You can do
I,
individually, both
yes.
parallelly.
Okay, fine, fine. So, would you like to introduce yourself? I would want to know about yourself. So,
Yeah, okay. Sir, I would
yeah,
introduce first.
yeah.
I'm Prachi. I'm Prachi Nangaonkar. I am basically belongs from Hoshangabad district, MP. I have done my BTech from RGBB University with 77 percentage. After that, I joined AmTech with now. Currently, I am doing AmTech in VLSI domain with 8.08 CGPA. Actually, I'm interested in electronic device domain, so I take my MTech thesis project in the based on nanosheet. Nanosheet. That's why my thesis project.
Okay. What are the other projects that you have done throughout your BTech or in MTech?
Sir, in MTech, I have basically done a project related to nanosheet. Then after that, FinFET, and currently I'm working on the material that is based on perovskite.
One small question: why do we go for FinFET? Why not CMOS technology?
Yeah, so sir, actually, I'm interested in the deep part of that nano sheet. So that's why I choose that domain for
No,
my.
no. You said that you have done something related to FinFETs,
Yeah,
right?
yeah.
So why that industry has moved from CMOS to FinFET? Can
Yeah.
you list some reasons?
Yeah, sir, that's the basic because in FinFET there is a structure just like that. There is like CMOS is current when in CMOS when we control current, then it is having there is some issue in that CMOS. So we use FinFET because it completely like it covered the gate, it covered the channel region in three sides that we are able to control current in that manner. So we moved from CMOS to FinFET, and after that we moved to nanosheet because it covered channel region in all four regions, all four sides.
Okay, good, good. So I would like to know about Maya now. Maya, would you like to introduce yourself, please?
Yes, sir, sure. Myself, hello everyone. My name is Maya Kore. Currently, I'm pursuing my Bachelor of Engineering in Electronics and Telecommunication from Government College of Engineering and Research, Ausari, Pune. I basically from Maharashtra, district Ahmednagar. I did my schooling from that town itself. After that, I secured the. I did my schooling with the 92 percentage in the CET exam and enrolled in the same college. Apart from this, I have done some mechatronics trainings and PLC programming and interested in VLSI domain. That's it. And my hobbies are sports and all. And I was not I'm not prepared. I just
Hmm.
joined this call just for
Okay,
like seeing others.
okay, fine, fine, fine. Okay, Prachi, let's get into this. Are you interested in front end or back end? Like, are you interested towards the Verilog part or towards the physical design domain part?
No, sir, in
So,
very low part.
okay, fine. Can you just briefly make us walk through the ASIC flow to begin with?
Sir, actually, I was not that much prepared. I just currently I prepared digital and Verilog means sir told just now I joined because of
Hmm.
so I was not.
Fine, fine, no issues, no issues.
So it may be had
So,
tomorrow, so I was prepared for that.
no issues, no issues.
Yeah. So you can ask
So,
little.
mm, um, uh, so okay. What are the difference between latch and a flip flop?
Yeah, in latch and flip flop. Flip flop is basically depend on clock. Like in latches, it doesn't depend on clock, but flip flop it depend on clock. And latches speed of latch is more than that of flip flop as compare if we compare to that. And so that,
Okay. So, what are the applications of flip flops?
So flip-flop is basically used in counter,
Mm-hmm.
all the SR flip-flop, D flip-flop, all the flip-flops are there, four types of flip
Mm-hmm.
and counter, all these devices, which is depend on clock basically. And it is memory storing element. So whatever we use in for storing purpose, flip-flop is basically storing element, but when we in timing analysis of the circuit, that's why we use flip-flop in that.
Okay. What was the one major issue with the flip flop? Do you find any issues with flip flop?
Yes, sir. There is race around condition in JK flip-flop that we overcome in by using master slave flip-flop.
What exactly is race around condition?
Yeah, sir. Race around condition is basically when we give input to the J terminal and K terminal. When we give input high to both terminal, then it's like its propagation delay time and clock time is vary. Propagation delay time is greater than that clock time.
Mm-hmm.
Input time is greater than propagation delay time. So because of propagation delay, the input is continuously vary 1 to 0, 0, 0 to 1, and when we take the output, then it is continuously varied 0 to 1 to take,
Mm-hmm.
and it's sir, it's setup and hold condition. It's a metastable condition. Basically, we say that it start the meta means that the when that we get the output, then we couldn't find the exact output. What maybe it is 0, maybe it is 1. So it is metastable condition occur in that. That's why that is race around.
So, what are the ways that we avoid race around condition?
Yeah, sir, in the basics parts, like if we take a input clock input clock width is greater than propagation delay of the circuit. First condition is that, and second is if we use master slave flip flop, it gives some delay, like slave provides some delay. So second condition is that, and the third one is like we use setup, like we use setup time. We check the setup time and hold time. Both are the time.
Mm-hmm.
When we check these times and give it input in this manner, so we get the output.
Okay, fine, good, good. So, name few differences between the combinational and sequential circuits.
Yeah, few differences. Combinational circuit. In that combinational circuit, there is no memory element. It provides suddenly better. Latches is the same. Whatever we give the input, it suddenly gives the output. But in sequential, there is some memory element or there is feedback is required in sequential circuit. So the basic difference is memory element is given in sequential, and in combinational there is no requirement of memory circuit or feedback.
Okay.
And different types of circuits are there in combinational. And sir, can I give the name also?
Examples, yeah, examples of combinational and sequential.
Yeah, in combinational there is like multiplexer,
Mm-hmm.
demultiplexer, decoder, encoder. All these circuits are used in combinational circuit
Okay.
because it gives the input and just give whenever we give input, it gives the output. And for sequential, there is JK flip flop. All types of flip flops are there. Counters are there. Means major application in the part of sequential only.
Okay, fine. So, what is a multiplexer?
Yeah, multiplexer
Mm.
is basically when we give many inputs to the multiplexer, it gives a single output. Like in our like example in our home or in some areas like offices, whenever we should
Mhm.
provide many computers in the same. I can't get the exact name, but whenever give it the input, but whenever we want one switch at a time, then we used multiplexer. It just switch off the other condition and just take the output only at a time and
Okay.
the output.
To implement n cross 1 mux, how many 2:1 mux we need?
To implement n cross 1, there
Mm.
is 2 to the power n. Uh,
Mhm.
for n's and
Okay, let's make it simple. For to implement a 4 to 1 mux, how many 2 to 1 mux do we need?
it's 3, sir.
To implement 8, how many do we need?
To implement 8, 4, 5, 6, 7.
Yeah.
Wait.
So basically it is n minus 1.
Yeah.
Yeah.
Right. Sir.
Good. So do you have a pen and paper, or
Yes, sir.
because I'm going to ask you very long questions.
Yes, sir. So
So
very
let's begin overlay now.
yeah.
Yeah. So what are the differences between double equal to and triple equal to? You might have gone through them.
Yeah.
So yeah. So what's the exact differences between the two?
So double equal is basically like when we check like there is three type of like data type 0, 1, X, Z, and if we give the input, if we compare two digits, not two
Mm-hmm.
digits, if we compare two numbers, it may
Mm-hmm.
be 0, 1, X, Z or 0, 1, X, X. So
Mm-hmm.
was double equal just to show the equality. Means if
Oh.
there is zero, I just give an example. If 0, 1, 0, X is the first number and second number is 0, 1, uh, 0x, then it gives the output is like 0. Means it is not
Mm.
equal. It is if it is exactly equal, then it gives the output is high. But
Okay.
in triple equal condition, there is conditionally stable, conditionally equality condition. Means
Yeah.
if it may be x, it may be so its output is the same number we have taken 0, 1, 0x, 0, 1, 0x. Then it may be 0 or it may be 1, so its output is x, means unknown state. It is the triple equal is conditionally equal, and the double equal is directly we just check the if both are numbers equal, then it gives the output high.
Okay. Okay. So good. What is the difference between blocking and non-blocking?
Yeah. In blocking statement, firstly is its sign. Like in blocking is equal to just sign, and the non-blocking is equal, and then one arrow is there.
Hmm.
Blocking condition, if like if the if some equations or if something has happened, like if some equations is happen, it blocks the other conditions. Like if some situation or if some operation is happen in a
Mm-hmm.
at the time, and the next operation, like if I just give example, like first is something is happening in first and the second, then it
Mm-hmm.
just stop the second operation up until the first operation may be completed. After the first operation is completed, then only we just start the second operation. And in non-blocking, it just started in like asynchronous manner. We say that in a asynchronous manner, the non-blocking statement is occur. Means in that timing is not added. Like first operation timing is 10 nanosecond and second is 20 nanosecond. So in non-blocking, it just like it is asynchronous basically, and the first one is blocking. It blocks the other statement up to until which the first is happens.
Okay. Mm. You might have heard about these constructs like dollar monitor, dollar display. So did you hear them?
Yeah, it's basically yes, sir. I just yeah, I learned it. You can ask.
Okay. So would you explain the difference between dollar display, dollar monitor, and dollar strobe?
Sir, I'm not sure, but whatever I just remember it. In dollar display, it display the like answer whatever we get. It just display the, and in dollar monitor, if we changes some input in between the full operation, then dollar monitor display that output.
Mm-hmm.
And
Dollar
in
strobe,
dollar, yeah,
dollar strobe.
dollar stroke, I can't remember. Sorry, sir, I
Okay,
can't.
fine, no issues.
Yeah.
So uh, let's move ahead. What is the difference between the initial block and the always block?
Sir, initial block is used in continuous assignment, and the always block is used in procedural assignment. Basic
Mm-hmm.
difference is that, and always block like initial statement, we can it is continuously run like initial and up to end module, and
Mm-hmm.
always statement. Sir, I can't get the exact answer, but always is used.
Is always synthesizable.
Always is, sir, in procedure. Sir, wait a minute. Always procedural statement. Procedural statement is, yes, sir. Sir, it is synthesizable because,
How are you saying that?
yeah, like I just thought that it is used in RTL synthesis, like in it is used. It is implemented in hardware part, so it is synthesizable. And if we
Mm-hmm.
can't implement, like in test bench, if it is used in test bench, then it is not synthesizable.
Okay, good. Good. So I would like you to write Verilog code for D flip flop.
Yeah.
Hello, sir. Am I audible?
Yeah.
Uh,
Yes. You are audible.
like, can you
You
switch
said
on?
that you were not prepared for this interview, so I stopped questioning you. Uh,
Actually, sir,
if you want me to ask,
I enrolled a few days ago, and today is my first day. So,
okay. So if you are prepared and if you want me to ask you questions, then I will go ahead and it is up to you know, it's your call.
yes, sir, sure. You can ask. Like, I would like to answer them.
Okay, let's get started with a few basic questions. What is the difference between a reg and a wire? Reg and a wire.
Actually, sir, as per my knowledge, register reg is used to store some information, and a wire is used to just hold the information. Both are
Okay.
variable.
So what is the default value for a reg?
Sorry, sir. Sir, I have not learned
Okay.
Verilog.
Okay. Hope you know gray code to binary code conversion.
Creo. No, sir.
I think you need some preparation, I guess. Maybe a day or two will be enough for you, I guess. Okay. Uh, okay, would you draw or gate using a 2x1 mux?
No, sir.
Okay. No issues. Take yourself some time. Uh, we'll arrange one more mock if you are ready with them. Uh, till that time, I think you go through the interview round which we are taking for Prachi. You will get a good experience from here and prepare accordingly. No worries. You will get back to the track. Don't get demotivated.
No, sir. I have just started the journey, so I'm willing to learn so many things.
Yeah, good.
Um, the, input is one, whatever the input, the output. Output is through Q. Else is equals to 50 is equals to 0. 0 time Sir, I can't get the hold condition. Like is it visible?
Would you please dictate it for me?
Yeah.
Just a second. Hold it that way. Hold it that way. Let me look into that.
So there is some
Um,
like module input D, the input and output. Then after that input output, then initial begin loop, then passage condition. Then
I think you need to once again check for the code. There is an error. There's a mistake.
yes, sir. There is. I am like stuck at that point. When D is 0, then there is hold condition, and I am not able to like show that hold condition in the code.
Hold. No worries. Yeah, put down your book. No issues. I've seen the code.
Okay.
Okay. Think about it. If you want few seconds time, we are ready to give it. Think about it. If you think you can do, then just let us know. We'll wait, or else we'll move forward.
So if D is 0, then
I would have helped you, but this is the basic in Verilog, I guess.
yes, sir.
It needs no help.
If D is 0, then it is D is 1, then Q.
Okay, let me make it easy for you.
Yeah.
Whenever it is holding, it should be like Q less than equal to Q. Whenever there is a clock, it must be Q less than equal to D. For hold condition, it is like Q is less than equal to Q. For whenever we are getting an input, it must be like Q less than equal to D.
Yes, sir.
Okay? And there you mentioned it is initial block. Actually, it must be always block.
Yes, sir. It's always block.
So just now you mentioned that always is synthesizable, and now you wrote initial. So there is a mistake there.
Yes, sir.
I'm actually correct it your way. And few more questions, digital questions I would like to ask. Would you please draw an OR gate using 2 cross 1 marks?
Is A plus B. A B bar plus B plus B bar. Yes, sir.
Show it.
So, one second, sir. A B bar plus B is equals to A plus B. B plus B bar is A plus B. Sir, is it visible?
Bring closer. Sorry. B. Would you explain this once?
Yes, sir. In the first
B plus B bar. Okay.
A and B bar. So A B bar plus second input is 1. So it is B. So A B bar plus B is A plus B.
Okay. Good. And what is a test bench?
Sir, test bench is like we synthesize, we draw our circuit by using RTL. Then, if we want to give it to give input to the circuit, so we use test bench for that.
So, would you please write a code for clock, generating a clock signal?
No, sir, I was not prepared for that. So, actually, I'm preparing theoretical part. I'm not compatible with that coding.
That coding is usually asked